Hello. In this video we're going to begin our discussion of all sorts of different types of functions, and we'll be starting today with linear functions, the most basic type of function that there is. Now a linear function is any function that you could write in this form here. Ax plus b, where a and b are just some real numbers. Of course, I guess a can't be 0. And the graph of this function is easy to study. It's going to be a line, a straight line. It's got a slope a, so that's the significance of this a value here, and a y-intercept at 0b, so that's the significance of the other parameter. So we can very easily draw the graph of any line that we find. So for instance, if we take negative 2x plus 3, we know that it has a y-intercept of 3 and a slope of negative 2. Now a slope is just the rise over the run, so it's a ratio. We can think of negative 2 as a fraction, negative 2 over 1, so we're going down 2 units for every 1 unit we go to the right. So if I take my y-intercept here at 0, 3, I'll be going down to the right as I move. So my line looks something like this. If I wanted to, I could find the x-intercept too, just to give me another point on the line, help the reader see exactly what this line is. And of course, to find an x-intercept, I just take my function, set it equal to 0. So I can easily solve that. And so that's this x-coordinate right here. Okay. Very simple. You've got your slope and your y-intercept. So let's talk about how you can find the equation of a line if it hasn't been given to you. Now I've got a very nice formula for you here. I'd like you to memorize this formula. It'll be the first formula you need to memorize in this course. And it basically comes out of the slope formula. You can see delta y is equal to m times delta x, or m equals delta y over delta x. Now what are these things? M is the slope. Y is the variable y. You're not going to replace it with anything. Now remember, when you get the equation of a line, you want it to be y equals something. Okay, so you need to have a y in your final equation. That's the y that's sitting right there. Now the y naught is the y-coordinate of a particular point on the line. This x naught over here is the x-coordinate of a particular point on the line. And the x, that's the last thing, is the variable x. Again, we need to have an x, actual symbol x, in our final equation, and that's it right there. So how do we use this nice formula here? It's really simple. Okay. Here we've got a line that has slope 7. So that's going to be our m value, and we have a particular point on this line. So our x naught is negative 1, our y naught is 4, and again the slope, I guess we're calling that m, is 7. So I just need to put everything in place from the above formula. So y minus 4 is equal to 7 times x minus negative 1. Okay. So we have here y minus y naught is equal to m times x minus x naught. And now all I need to do is just expand and simplify. There's no solving and things like that. Of course, x minus negative 1 is just x plus 1. I can distribute the 7 and then just bring the adding 4 to both sides brings the 4 over. So there we have it. The equation of our line in slope y-intercept form is y equals 7x plus 11. Very simple, and you can use that formula at the top of the page. It works wonders. Now, if you think about lines, there's two different ways I could tell you about a line. I could either give you the information about its slope and a single point. If I tell you a point and the slope, there's only one line that has those two properties. Another way to give you the information you need for a line is to give you two different points on the line. We all know that there's a unique line that goes through any pair of distinct points. So, with that in mind, we should be able to find the equation of a line if we've just been given two distinct points on the line. And it's pretty straightforward. Of course, if we have 2 points, we can just go ahead and calculate the slope. So our slope, often we use a little formula delta y over delta x. Delta is a Greek letter, and in this context it means the change in y, the change in x. So we're looking for the difference in the y values of our 2 points. So that would be, let's take -3 minus -2 over the difference in the x values of our 2 points. We need to keep the order the same. And we just calculate this. -3 plus 2 over 1 plus 8. And we get -1 over 9 as our final slope. And now, what have we got? We've got our m value, it's -1/9, and we have a point on the line. You can choose either one, it really doesn't matter. You'll get the exact same equation for the line either way. So, I'm going to use my formula at the top of the page. Okay, I have my point x0, y0. I can choose either one of them. I have my m, my slope, it's -1/9, and I'll use that formula. So we have y minus, why don't I use that second point? So y minus -3 is equal to -1/9 times x minus 1. So I've got y plus 3, and I can distribute on the on the right hand side, -1/9 x plus 1/9. And then I just have some fractional arithmetic to do, because I need to subtract 3 from both sides. Well, how about as I bring that 3 over to the other side, instead of just subtracting 3, why don't I subtract what it should be in terms of ninths? And 3 is 27 over 9. If I take 3 over 1 and multiply top and bottom by 9, I get 27 over 9. And now we can very easily add our fractions together, now that we've got a common denominator. So there's our line in slope y-intercept form. And this is it. These are the only two ways that you need to know how to find the equation of a line, either given the slope and a point on the line, or given 2 points. We'll look at quite a few examples involving the applications of finding linear equations and graphing them in class. And please take some time to do your web work and work on some examples finding equations of lines for yourself.